October 14, 1943, Thurley Airfield, England. 6:42 a.m. 381 B-17 Flying Fortresses stood on runways across East Anglia, engines warming in the pre-dawn cold. Crews climbed aboard, knowing they faced a mission 400 miles deep into Nazi Germany. The target, 5 factories in Schweinfurt that produced ball bearings. Not tanks, not submarines, not aircraft plants. Ball bearings. Tiny steel spheres, most smaller than a marble. Components that seemed insignificant. Parts that German commanders never thought would matter. But American intelligence believed those bearings held the key to ending the war. Destroy them, and Germany's war machine would grind to a halt. Tanks wouldn't move. Aircraft couldn't fly. Submarines couldn't dive. The mission was codenamed Operation 115. By nightfall, it would earn another name, Black Thursday. 60 B-17s would be shot down. 600 men would never return home. The losses would be so catastrophic that deep penetration bombing raids into Germany would be suspended for 4 months. But the question haunting military planners wasn't about the cost. It was whether tiny ball bearings could actually win a war. The Germans laughed at the idea, until they stopped laughing. The component? Nobody expected 1941. London, England. British Ministry of Economic Warfare. Analysts studied intelligence reports about German industrial production. They searched for bottlenecks, critical components that, if disrupted, would cascade through Germany's entire war economy. Oil refineries were obvious targets. Aircraft factories made sense. Tank production plants were logical. Then analysts noticed something peculiar in German production data. Ball bearings. Every tank required between 400 and 2,000 ball bearings depending on size. Every aircraft needed 1,000 to 3,000. Submarines used 2,500. Artillery pieces required several hundred. Trucks needed 300. Everything that moved, rotated, or had moving parts required ball bearings. Without them, friction destroyed machinery within hours of operation. British analysts discovered their own vulnerability the hard way. In 1940, German bombers hit a British ball bearing factory. Aircraft production immediately slowed by 30%. The shortage lasted 6 weeks. If one factory could cause that much disruption, what would happen if Germany lost its primary ball-bearing production? The answer came from examining German industrial organization. Unlike Britain or the United States, which had dispersed ball-bearing production across multiple regions, Germany had concentrated most of its production in one city, Schweinfurt. 5 factories in Schweinfurt produced between 40 and 55% of Germany's total ball-bearing output, depending on various estimates. The Kugelfischer plant produced 22%. Vereinigte Kugellagerfabriken I and II produced 20%. Fichtel and Sachs accounted for 1%. Other smaller facilities produced the remainder. This concentration created vulnerability. Destroy Schweinfurt's factories, and Germany would face immediate shortages. Those shortages would propagate through every weapon system simultaneously. The British Ministry of Economic Warfare designated ball bearings as the second most vital target for the combined bomber offensive after aircraft production. American planners agreed. Albert Speer, Germany's armaments minister, had warned Adolf Hitler about this exact vulnerability. On September 20, 1942, a full year before the first Allied raid, Speer told Hitler, "The tank production at Friedrichshafen and the ball-bearing facilities in Schweinfurt are crucial to our whole effort. If we lose them, armament production will suffer catastrophically within 4 months." Hitler dismissed the concern. Who would target ball bearings? They were too small, too insignificant to matter strategically. Bombers would target cities, factories, infrastructure, not tiny metal spheres. But Allied intelligence had identified the precise weakness Speer feared. Ball bearings weren't just important, they were irreplaceable. The physics nobody understood. Understanding why ball bearings mattered requires understanding friction. When two metal surfaces slide against each other under load, friction generates heat and resistance. In a tank transmission without ball bearings, metal gears grinding against each other would generate temperatures exceeding 500 degrees Fahrenheit. The metal would expand, warp, and seize within an hour of operation. The tank would become immobile. Ball bearings solve this problem through a simple principle. Instead of surfaces sliding against each other, they roll. Tiny steel spheres placed between rotating parts carry the load while rolling with minimal friction. The reduction in friction is dramatic. A shaft rotating in a plain bearing experiences friction roughly 20 times greater than the same shaft supported by ball bearings. This means 20 times more force required to turn it, 20 times more heat generated, 20 times faster wear. For high-speed applications, aircraft engines, tank transmissions, submarine propeller shafts, ball bearings weren't just advantageous, they were absolutely essential. German aircraft engines operating at 2500 RPM would overheat and fail within minutes without ball bearings. Tank engines would seize. Submarine propeller bearings would destroy themselves. But manufacturing ball bearings to the precision required for military applications was extraordinarily difficult. Each bearing had to be perfectly spherical to within 0.011 inches. The steel had to be hardened to exact specifications. Too soft, and the bearings would deform under load. Too hard, and they would shatter. The manufacturing process required specialized machinery, skilled workers, and months of production time. You couldn't improvise ball bearing production. You couldn't substitute inferior materials. You either had precision ball bearings or you had non-functional equipment. This created the strategic vulnerability Allied planners identified. If Germany lost its ball-bearing production, it couldn't quickly replace it. Factories would take years to rebuild. Machinery would take years to manufacture. Skilled workers would take years to train. Meanwhile, every tank, aircraft and submarine coming off German production lines would sit immobile, waiting for bearings that didn't exist. The neutrality nobody questioned. But Allied planners overlooked one critical factor: Sweden. Svenska Kullagerfabriken, SKF, was the world's largest ball-bearing manufacturer. Founded in Gothenburg in 1907, SKF had pioneered the self-aligning ball bearing. By 1940, SKF controlled 58% of Germany's ball bearing supply. It also supplied 31% of Britain's bearings. Sweden maintained official neutrality throughout the war, but neutrality meant trading with both sides. Germany needed Swedish iron ore and ball bearings. Britain needed the same bearings to maintain war production. The diplomatic balancing act was extraordinary. Sweden sold bearings to Germany through direct export and through SKF subsidiary factories operating in German-controlled territory. Simultaneously, Sweden allowed Britain to smuggle bearings through the German blockade. The smuggling operation was called Operation Bridford. British agents operating in Stockholm purchased SKF bearings. The bearings were transported to neutral ports. Fast ships, often disguised as civilian vessels, ran the German blockade. British aircraft, including de Havilland Mosquitoes painted in civilian BOAC livery, flew from Scotland to Stockholm and back carrying ball bearings. Over the course of the war, these aircraft transported 500,000 tons of freight, including thousands of tons of ball bearings. The flights were dangerous. They flew over occupied Norway. German fighters occasionally intercepted them, but enough flights succeeded to maintain critical British bearing supplies. The price arrangements revealed Sweden's calculated neutrality. In 1938, SKF charged Britain 74% of what it charged Germany for the same bearings. As the war progressed and Germany's position weakened, Swedish prices to Germany increased dramatically. Britain received discounts. Germany paid premiums. Allied intelligence discovered the extent of Swedish exports in 1942. American and British diplomats pressured Sweden to reduce ball-bearing sales to Germany. The Swedish government agreed in principle, but honoured existing contracts. In 1943, Sweden agreed to limit bearing exports to Germany to 29 million kronor, about a third below 1943 levels. But enforcement was inconsistent. SKF continued shipping bearings through subsidiary companies and neutral intermediaries. Some analysts later claimed Swedish bearings prolonged the war by 2 years. This assessment is controversial. Germany had multiple bearing sources. Swiss manufacturers supplied bearings. Italian factories under Axis control produced bearings. Germany's own domestic production, even after bombing, remained significant. But the Swedish connection frustrated Allied planners. Every raid on Schweinfurt could be partially offset by Swedish imports. American bombers died attacking factories while Sweden shipped replacement bearings. The moral implications troubled some Swedish citizens. After the war, investigations revealed that SKF had actively worked to maintain German supply even after pledging to reduce exports. Bearings were smuggled when direct export became politically untenable. SKF sold bearing manufacturing machinery to Germany as late as 1945. The Swedish government's position was pragmatic. Surrounded by German-occupied territory, dependent on German goodwill for territorial integrity, believing that maintaining economic ties was essential to avoiding invasion. Britain received bearings through blockade running. Germany received them through direct trade. Both sides paid. Sweden profited. This reality complicated the strategic calculus. Destroying Schweinfurt mattered, but it didn't eliminate Germany's bearing supply. It only made Germany more dependent on Swedish imports. The raid nobody survived, August 17, 1943. 5:47 a.m., the first raid on Schweinfurt was part of a dual-target mission. 184 B-17s would attack Schweinfurt. Another 147 would hit the Messerschmitt aircraft factory at Regensburg. The plan was clever. By splitting the force, planners hoped to divide German fighter defences. The Regensburg force would attack first, drawing Luftwaffe fighters. 10 minutes later, the Schweinfurt force would follow, catching German fighters on the ground refuelling. The plan failed immediately. English fog delayed takeoff. The 30-minute separation between forces became 3.5 hours. German fighters had ample time to attack both formations. The Schweinfurt force crossed into German airspace at 2 p.m. P-47 Thunderbolt escorts turned back at the German border. They lacked the range to penetrate deeper. For the next 2 hours, the B-17s flew unescorted through German fighter-controlled airspace. 300 Luftwaffe fighters attacked: Messerschmitt Bf-109s, Focke-Wulf Fw-190s, Messerschmitt Bf-110 heavy fighters. Even Junkers Ju-88 night fighters pressed into daytime service. German pilots employed tactics specifically designed to break bomber formations. Head-on attacks from 12 o'clock high, diving through the formations at 400 miles per hour. Rocket attacks from beyond machine gun range. Concentrated fire on lead aircraft to disrupt bombing accuracy. The 305th Bomb Group lost 13 of its 16 B-17s in minutes. The 91st Bomb Group lost 43% of its crews. The 381st lost 50%. B-17s fell from formation trailing smoke and flame. Parachutes dotted the sky as crews bailed out. Some aircraft exploded in mid-air when fuel tanks ignited. Others spiraled down, control surfaces shot away. At 2:39 p.m. the surviving bombers reached Schweinfurt. Through smoke and flak, bombardiers sighted their targets. Despite the chaos, bombing accuracy was exceptional. The Kugelfischer and Vereinigte Kugellagerfabriken plants suffered 80 direct hits. 35,000 square meters of factory buildings were destroyed. Another 100,000 square meters suffered fire damage when incendiaries ignited machine oil. Then came the flight home. German fighters attacked continuously as the B-17s limped back toward England. Aircraft with damaged engines fell behind, easy prey for marauding fighters. Bombers with wounded crew or damaged systems struggled to maintain altitude. By the time survivors crossed the English coast, the losses were staggering. Of 184 B-17s that attacked Schweinfurt, 36 were shot down. Another 27 returned so heavily damaged they were scrapped. 121 had varying degrees of battle damage. Total crew losses: 370 men killed or captured. Albert Speer received damage reports within 24 hours. Ball-bearing production had dropped 34% immediately. Production would fall from 140 tons in July to 69 tons in August, to 50 tons in September. Speer immediately convened his staff. "We anxiously asked ourselves," he later wrote, "how soon the enemy would realize that he could paralyze the production of thousands of armament plants merely by destroying 5 or 6 relatively small targets." The answer came 2 months later. Black Thursday, October 14, 1943, 10:00 a.m. The second Schweinfurt raid launched with 291 B-17s. Planners had learned lessons from August. This time the entire force would hit Schweinfurt simultaneously. Fighter escorts would cover the outbound and return legs as far as possible. The bombing would be concentrated, overwhelming. What planners didn't know was that German defences had been reinforced dramatically. After the August raid, Germany pulled virtually every fighter from the Eastern Front to protect Western industry. Instead of 300 fighters, the Schweinfurt force would face 800. The formation crossed into Germany at 11:38 a.m. P-47 escorts turned back near Aachen, just inside the German border. For the next 3 hours, the bombers flew alone. The Luftwaffe attack was unprecedented in magnitude and coordination. Fighters attacked in waves, each wave fresh, while the previous wave landed to refuel and rearm. Twin-engine Bf-110s fired 21 Seemeter rockets from beyond effective defensive range. Single-engine fighters pressed attacks to point-blank range, some colliding with B-17s. Lieutenant Colonel T.R. Milton, leading the 91st Bomb Group, described the scene. "German fighters were everywhere, above, below, on both sides. Some were attacking, others positioning for their next pass. The sky was filled with tracers, smoke trails, and debris. The 305th Bomb Group lost 130 men, 87% of its strength. The 306th lost 100 men. Entire squadrons were decimated." At 2:39 p.m., the lead bombers reached Schweinfurt. Despite the carnage, the surviving bombardiers remained focused. Bombing accuracy was superb. The 40th Bomb Group placed 53% of its bombs within 1,000 feet of the aim point. Of 1,122 bombs dropped, 143 landed in the factory area, with 88 direct hits. Albert Speer later confirmed the devastation. Ball-bearing production dropped 67%. Output fell to 29% of pre-raid levels. But the cost was catastrophic. 60 B-17s were shot down, 20.6% of the attacking force. Another 17 returned, so damaged they were scrapped. 121 limped home with battle damage. Total casualties: 650 men. 594 listed as missing in action. Most were dead or would spend the rest of the war in prisoner camps. At Thurley Airfield, home of the 306th Bomb Group, only 5 B-17s returned from the 15 that launched. The scene was repeated across East Anglia, empty hardstands where bombers should have parked, ground crews waiting for aircraft that would never return. General Henry Hap Arnold, commanding the Army Air Forces, publicly claimed the losses were incidental to the mission's success. Privately, he knew the truth. At this loss rate, bomber crews had virtually no chance of surviving a 25-mission combat tour. The mathematics were brutal. At 20% losses per mission, a crew would survive an average of 5 missions. Deep penetration raids into Germany were suspended immediately. The 8th Air Force would not return to targets beyond fighter escort range for 4 months, not until long-range P-51 Mustangs became available. Black Thursday had proven that unescorted bombers, no matter how heavily armed, could not survive against determined fighter opposition. The doctrine of "the bomber will always get through" died over Schweinfurt. The recovery nobody prevented. But did the raids actually work? Did destroying Schweinfurt's factories cripple German war production as Allied planners predicted? The answer is complex and controversial. Albert Speer's immediate response was panic. Production had dropped 67%. Existing stocks would last 6 to 8 weeks. After that, weapons production would collapse. Speer couldn't immediately relocate the factories. Moving production meant stopping production, which Germany couldn't afford. So German industrial plants sent workers with knapsacks to Schweinfurt daily to collect whatever bearings were available. Aircraft factories adjusted production schedules based on bearing availability. Tank plants slowed. For 6 weeks, Germany's war production teetered on collapse. Then 3 factors saved German industry. First, Germany had accumulated enormous stockpiles of ball bearings before the war. Speer had ordered increased production in 1942 specifically because he feared Allied bombing. Those reserves, hidden in warehouses throughout Germany, covered the immediate shortfall. Second, Germany imported ball bearings from neutral countries. Sweden's SKF company supplied approximately 58% of Germany's ball bearing needs through direct exports and subsidiary operations. Switzerland contributed additional supplies. Italy, still under Axis control in late 1943, provided bearings. Third, German engineers redesigned equipment to use fewer bearings. Slide bearings replaced ball bearings in non-critical applications. Existing bearings were reconditioned and reused. Standards were relaxed for equipment not requiring precision. Within 6 months, Schweinfurt's factories were repaired and operating. Dispersal began immediately. Production moved to smaller facilities across Germany. By 1945, Germany had more ball bearing reserves than before the raids. The dispersal nobody prevented Albert Speer moved with characteristic efficiency after the raids. He appointed a special overseer for ball-bearing production with priority access to resources. The overseer's mission: disperse production to make it invulnerable to bombing. Within weeks, machinery was being moved from Schweinfurt to dozens of smaller facilities. Factories in Erkner, near Berlin, plants in Stuttgart, Schweinfurt's only remaining large facility, smaller workshops scattered across Germany, underground facilities in old mines. The dispersal was enormously costly. Moving precision machinery damaged calibration. Setting up new facilities took months. Training workers in new locations consumed time. Quality control suffered when production was fragmented. But it worked. By mid-1944, bombing Schweinfurt could no longer cripple German bearing production. There was no single target to hit. Production was distributed across hundreds of locations. Allied bombers would need to hit every facility to achieve the same effect as the 1943 raids. The dispersal revealed a fundamental limitation of strategic bombing. Against concentrated targets, precision bombing could be devastating. Against dispersed production, even successful raids had limited impact. German engineers simultaneously worked to reduce bearing requirements. They redesigned tank transmissions to use 30% fewer bearings. Aircraft engines were modified to substitute slide bearings where precision wasn't critical. Existing bearings were reconditioned instead of replaced. The German military relaxed specifications for non-critical applications. Training aircraft could use lower quality bearings. Trucks operating behind the lines didn't need precision bearings. Reserve requirements were reduced. These measures had costs. Equipment reliability suffered. Maintenance increased. Some weapons systems performed below original specifications, but Germany maintained production. Tanks continued rolling off assembly lines. Aircraft continued flying. Submarines continued diving. The question wasn't whether Germany had enough bearings. By 1944, through dispersal, imports, redesign and reserve usage, Germany had adequate supplies. The question was whether those measures consumed resources that Germany couldn't afford. Speer later calculated that dispersal reduced efficiency by approximately 40%. Producing the same number of bearings required 40% more workers, machinery, and materials. Those resources came from other military production. The engineering effort to reduce bearing usage consumed thousands of hours that could have been spent improving weapon systems. The workers moving machinery could have been building tanks. The transportation network moving bearings between dispersed facilities could have been moving ammunition. This was the hidden cost of the Schweinfurt raids, not immediate production collapse, but forced inefficiency that cascaded through the entire war economy. So did the raids fail? Not according to Albert Speer. In his post-war memoirs, he wrote, "The Allies threw away success when it was already in their hands. If they had followed up the Schweinfurt raids with sustained bombing, German armament production would have collapsed. Instead, they gave us time to recover." Speer stated unequivocally, "The war could largely have been decided in 1943 if instead of vast but pointless area bombing, the planes had concentrated on centers of armaments production." The US Strategic Bombing Survey concluded, "There is no evidence that attacks on the ball-bearing industry had any measurable effect on essential war production." But the same survey noted, the outcome might have been different had the 8th Air Force been able to follow up on the 1943 attacks. The truth lies between these assessments. The raids demonstrated that ball bearings were indeed a critical vulnerability. Production did collapse. German war production did suffer. But sustained pressure was required to make that collapse permanent. 2 raids separated by months gave Germany time to adapt, disperse, and recover. The fighter nobody wanted the solution to the bomber losses came from an unexpected source. The P-51 Mustang had been rejected by the US Army Air Corps in 1940. It was designed for Britain, powered by an Allison engine that performed poorly at high altitude. But in 1942, the British fitted a Rolls-Royce Merlin engine to a Mustang airframe. The results were extraordinary. The Merlin's 2-stage supercharger gave the Mustang outstanding high-altitude performance. Top speed jumped to 437 miles per hour at 25,000 feet. Service ceiling reached 41,000 feet. Most importantly, the P-51 had range. With external drop tanks, it could escort bombers 750 miles, enough to reach Berlin and return. It could fight and defeat German Bf-109s and FW-190s. It cost $51,000 compared to $150,000 for a P-47 Thunderbolt. In December 1943, P-51Bs began arriving in England. The 354th Fighter Group flew their first escort mission on December 13th. By February 1944, P-51 groups were operational across the 8th Air Force. On February 20th, 1944, 4 months after Black Thursday, Allied bombers returned to Schweinfurt. This time, 266 B-17s attacked in daylight. 734 RAF bombers followed at night. P-51 Mustangs escorted the American formation the entire way. German fighters attempting to attack the bombers encountered P-51s instead. The Luftwaffe lost 41 fighters. The 8th Air Force lost only 11 bombers, less than 5%. The difference was stark. October 1943 without escort, 60 bombers lost, 20.6% loss rate. February 1944 with P-51 escort, 11 bombers lost, 4.1% loss rate. The P-51 had fundamentally changed the air war. On February 28, 1944, the 4th Fighter Group received P-51s. They had the planes ready for operational flying within 24 hours. On March 4th, they escorted B-17s to Berlin, the first time single-engine fighters made the 100-mile round trip. They shot down 17 German aircraft. By April 1944, P-51s were conducting fighter sweeps, flying ahead of bomber formations to intercept German fighters before they could attack. By the end of 1944, 14 of the 8th Air Force's 15 fighter groups flew Mustangs. Hermann Göring, commander of the Luftwaffe, later stated, "The reason for the failure of the Luftwaffe against Allied air forces was the success of the Americans in putting out a long-range escort fighter. Without this escort, the air offensive would never have succeeded." Big Week, February 20th, 25, 1944. Operation Argument. With P-51 Mustangs now available in numbers, Allied planners launched an all-out offensive against German aircraft production. The goal wasn't just to bomb factories, it was to force the Luftwaffe into combat and destroy it. Over 6 days, the 8th and 15th Air Forces flew 3,800 bomber sorties. They dropped 10,000 tons of bombs on aircraft factories, component plants, and assembly facilities. Most importantly, they escorted every raid with swarms of P-51s under new orders, engage and destroy enemy fighters wherever found. The Luftwaffe had no choice but to defend. Industrial targets were critical. German fighters rose to intercept, and P-51s slaughtered them. On February 20th, the first day, American fighters claimed 61 German aircraft destroyed. On February 21st, 33 German fighters down. February 22, 59 destroyed. February 23rd, 44 destroyed. February 24th, Schweinfurt was hit again, 86 German aircraft destroyed. February 25, 64 destroyed. In 6 days, the Luftwaffe lost approximately 355 fighters in air combat. German pilot losses were catastrophic. Experienced pilots who'd survived years of combat were killed. New pilots with minimal training were thrown into battle and died within days. Production facilities suffered massive damage. The Messerschmitt factory at Regensburg was hit again. Focke-Wulf plants at Oschersleben and Halberstadt were devastated. Component suppliers throughout Germany were bombed. American losses were significant, but sustainable. 226 bombers lost over 6 days. 28 fighters lost. But bomber losses were 6%, down from 20% at Schweinfurt in October. The difference was the P-51. Jimmy Doolittle, commanding the 8th Air Force, had changed fighter doctrine fundamentally. Previously, fighters stayed with bombers. Now, fighters hunted German aircraft aggressively. The old motto, "Our mission is to bring the bombers back alive," was abandoned. Doolittle's new directive, "Your mission is to destroy the German Air Force." P-51s swept ahead of bomber formations. They attacked German fighters forming up to intercept. On the return flight, P-51s strafed German airfields, destroying aircraft on the ground. This aggressive doctrine had one goal: eliminate the Luftwaffe as a fighting force before D-Day. It worked. By April 1944, the Luftwaffe was unable to mount effective opposition. German fighters still flew. But pilot quality had collapsed. Veterans were dead or grounded by fuel shortages. Replacements had 20-30 hours of flight training compared to 200-300 hours pre-war. American bomber crews noticed the change. In October 1943, every mission faced hundreds of fighters. By May 1944, German opposition was sporadic and ineffective. The Luftwaffe's fighter arm had been destroyed, not by bombing factories, but by forcing combat against superior numbers of superior aircraft flown by better-trained pilots with unlimited fuel. Ball-bearing raids had forced this strategic pivot. Black Thursday proved bombers couldn't survive without escort. P-51 development accelerated. Fighter doctrine changed. The result was destruction of German air power. The final missions. The 8th Air Force returned to Schweinfurt twice more. February 24, 1944, part of Big Week, March 16, 1944. Both raids were escorted by P-51s. Both achieved heavy damage with minimal losses. German ball-bearing production continued declining. But by mid-1944, ball bearings were no longer a priority target. German production had dispersed too thoroughly. Swedish imports continued. German reserves remained adequate. Allied bombers shifted to oil production. Petroleum refineries became the critical target. By September 1944, German fuel production had collapsed. The Luftwaffe was grounded not by lack of aircraft, but lack of fuel. The ball-bearing offensive had succeeded in forcing strategic changes. It failed in its original goal of crippling production through targeting a single bottleneck. The lessons shaped post-war strategic bombing doctrine. Single-point failure analysis became critical, but so did understanding backup supplies, substitution, and dispersal. Modern military logistics incorporates multiple redundancies. No single factory produces critical components. Stockpiles buffer against disruption. Alternative suppliers are identified in advance. Because Schweinfurt taught what happens when you concentrate production of a critical component in one location, you create vulnerability, and your enemy will exploit it. The truth nobody admitted. Post-war analysis revealed uncomfortable truths about the ball-bearing offensive. British Air Marshal Arthur Harris had opposed targeting ball bearings from the beginning. He called them a panacea target, one of many supposed miracle solutions to ending the war. Harris preferred area bombing of cities. Post-war evidence proved Harris partially correct. Germany never suffered critical ball-bearing shortages after the initial raids. Stockpiles, imports and design changes compensated for reduced production. No tank, aircraft or submarine failed to be produced due to lack of bearings. But this doesn't mean the raids failed. The raids forced Germany to disperse production to hundreds of smaller facilities. This dispersal was enormously inefficient. Production costs increased. Quality control suffered. Transportation of components between facilities consumed resources. The raids forced Germany to import bearings from neutral Sweden at high cost. This diplomatic pressure eventually led to reduced Swedish exports. The raids forced German engineers to redesign equipment to reduce bearing usage. This consumed engineering resources needed elsewhere. Most importantly, the raids demonstrated what sustained pressure on critical industries could achieve. The February 1944 raids, supported by P-51 escorts, were part of Big Week, a coordinated six-day offensive against German aircraft production. That campaign devastated the Luftwaffe's ability to replace losses. By D-Day, June 6, 1944, the Luftwaffe had been reduced to a shadow force. Allied aircraft flew 14,000 sorties on D-Day. The Luftwaffe flew 2. Albert Speer's assessment remains the most revealing. He believed the ball-bearing raids came closer to crippling German production than any other strategic bombing campaign. The problem wasn't the concept, it was execution. 2 raids separated by months allowed recovery. Sustained pressure would have succeeded. The component that mattered. So did ball bearings win the war? Not directly. No German tank sat immobile waiting for bearings. No aircraft remained grounded. Production continued throughout the war. But the ball-bearing raids achieved something more significant. They proved that strategic bombing could target specific industrial bottlenecks. They demonstrated the critical importance of long-range fighter escorts. They forced complete reorganization of the American bombing campaign. After Black Thursday, American strategy changed fundamentally. Instead of targeting factories, the priority became destroying the Luftwaffe itself. P-51 Mustangs hunted German fighters aggressively. Fighter sweeps preceded bomber formations. Strafing attacks destroyed aircraft on airfields. This strategy worked. By spring 1944, the Luftwaffe was finished as an effective fighting force. German fighter pilots were being thrown into combat with minimal training. Fuel shortages grounded experienced units. Aircraft production couldn't replace losses. Allied bomber losses dropped dramatically. In October 1943, 9.1% of bombers failed to return from missions. By February 1944, that figure fell to 3.5%. By June 1944, it was below 2%. This made possible the massive bombing campaigns that destroyed German oil production, transportation networks, and industrial capacity. Without air superiority, achieved partly through lessons learned at Schweinfurt, those campaigns would have been impossible. The tiny ball bearings that seemed insignificant changed military strategy. They forced recognition that precision targeting mattered. They demonstrated that no bomber could survive without fighter escort. They proved that industrial warfare required attacking critical components, not just buildings. The men who paid the strategic lessons came at brutal cost. At Thurley Airfield on October 14, 1943, ground crews waited for bombers that never returned. Mechanics who'd worked all night preparing aircraft stood watching empty skies. Operations officers crossed names off rosters. The 306th Bomb Group lost 100 men that day. The 305th lost 130. Most died in the air, killed by cannon fire, consumed by flames, or lost when aircraft disintegrated. Some survived to parachute into Germany, spending the rest of the war in prisoner camps. A few evaded capture and returned to England months later. Second Lieutenant Charles Cruikshank, piloting Jersey Bounce Jr., watched 3 engines fail over Schweinfurt. He kept the damaged B-17 flying long enough for his crew to bail out. He went down with the aircraft. Staff Sergeant Edward Michael, ball turret gunner on Patches, was hit by 20mm cannon fire. His turret jammed. The crew couldn't extract him before the aircraft went down. The experience nobody forgets. Flying a B-17 on a Schweinfurt mission meant 10 hours of terror punctuated by moments of absolute horror. Crews woke at 3 a.m. for briefing. When the curtain pulled back, revealing Schweinfurt on the map, men groaned. Everyone knew what that target meant. Breakfast was usually skipped. Nerves made eating impossible. Some men vomited before boarding. The flight to Germany took 3 hours. Over the North Sea, P-47 escorts joined the formation. Their presence provided brief comfort. At the German border, escorts turned back. Fuel exhausted, they waggled wings and dove toward England. The bombers continued alone. German fighters appeared as dots on the horizon. Then the dots grew larger. Then they were everywhere. Messerschmitt Bf-109s attacking from 12 o'clock high. Focke-Wulf FW-190s raking the formation from below. Twin-engine Bf-110s firing rockets from beyond range. The noise inside a B-17 under attack was overwhelming. Machine guns firing continuously, cannon shells exploding, engines screaming, wind howling through holes in the fuselage. Watching other B-17s go down was nightmares made real. One moment, a bomber flew in formation. The next, it trailed smoke and flame. Parachutes appeared. Sometimes. Often the aircraft simply fell, spinning, crew trapped inside. Ball turret gunners had the worst position, suspended below the aircraft in a plexiglass sphere. If the aircraft was hit badly, there was no escape. The turret mechanism could jam. The crew couldn't extract them from inside. If the aircraft went down, the ball turret gunner died trapped in his bubble. Waist gunners fired at fighters flashing past at 400 miles per hour. The German fighters moved so fast that gunners led their targets by pure instinct. Hit rates were perhaps 1 in 1,000 rounds, but they kept firing because the alternative was watching fighters attack unmolested. Pilots fought to keep damaged aircraft flying. 1 engine out, still flyable. 2 engines out, struggling. 3 engines out, time to consider bailing out. But damaged bombers falling behind formation were easy targets. German fighters concentrated on stragglers, so pilots kept flying as long as any control remained. Bombardiers focused on the target despite chaos. At Schweinfurt, the bomb run lasted approximately 4 minutes. 4 minutes flying straight and level while flak exploded around them. 4 minutes when evasive maneuvers were impossible. 4 minutes when German gunners had stationary targets. Then, bombs away. The aircraft lurched upward, suddenly 4,000 pounds lighter. Turn for home. But the flight home was worse than the inbound flight. Damaged aircraft struggled. Wounded crew bled. Ammunition was depleted. German fighters knew this. They saved aircraft and ammunition for the return flight. Fresh fighter units rose to attack the battered bomber formations. Some B-17s made it to the English coast before ditching in the North Sea. Crews scrambled into life rafts, hoping air-sea rescue would find them before hypothermia set in. Many were never found. Landing back at base, crews counted the cost. Who made it back? Who didn't? The empty hardstands told the story. 15 B-17s left from the 306th Bomb Group. 5 returned. 100 men gone. Ground crews painted mission symbols on aircraft noses. Bomb symbols for successful missions. After Schweinfurt, they painted fewer symbols. Too many aircraft weren't coming back to receive them. The mathematics nobody survived. The loss rates made completion of a combat tour mathematically improbable. Bomber crews were required to fly 25 missions before rotation home. At 20% loss rates, typical for deep penetration missions in late 1943, statistical survival was impossible. Mission 1, 100 crews deploy. After Mission 1 at 20% losses, 80 crews remain. After Mission 5, 32 crews remain. After Mission 10, 10 crews remain. After Mission 15, 3 crews remain. After Mission 20, 1 crew remains. After Mission 25, 0.3 crews remain. In other words, at 20% loss rates, less than 1 crew in 300 would complete a 25-mission tour. Crews knew these numbers. They watched new replacements arrive. They watched those replacements disappear. Some men broke mentally before physical injury. Flak happy. Psychological breakdown from sustained stress. Unable to fly. Tremors. Nightmares. Complete inability to function. Others flew until they were shot down or completed their tours. The ones who made it home often wondered why. Why them? Why did they survive when so many didn't? There was no answer. Survival was random. a shell exploding 3 feet left instead of 3 feet right, a fighter attacking a different aircraft, an engine continuing to run when it should have failed. These weren't names in a casualty report. They were farm boys from Iowa, mechanics from Detroit, college students from California. They were 19, 21, 24 years old. They came from small towns with names like Moline, Topeka, and Shreveport. Many had never been on an airplane before joining the Army Air Forces. Some had never left their home states. Now they were flying B-17s through flak and fighter attacks 400 miles into Germany, targeting factories most had never heard of, destroying components they didn't understand. The crew of Memphis Belle completed 25 missions, one of the first to do so. They became celebrities, touring America to promote war bonds. But most crews never came home. First Lieutenant Robert Morgan, pilot of Memphis Belle, later reflected, "We were so young. We thought we were invincible. Then we watched planes go down and realized we weren't." Second Lieutenant Charles Brown, B-17 pilot on the December 20th, 1943 mission to Bremen, was attacked by German ace Franz Stiegler. Stiegler could have shot him down easily. Instead, Stiegler escorted the damaged B-17 to safety, recognizing a fellow pilot in distress. They met decades later as friends. But at Schweinfurt, there was no mercy. The target was too important, the stakes too high. German fighters pressed attacks until bombers fell from the sky. They died because military planners believed ball bearings could end the war. The controversy over whether the raid succeeded misses this human reality. 600 men died attacking Schweinfurt in 2 raids. Thousands more died in subsequent missions against German industry. Their sacrifice forced changes that ultimately won the air war. But they never knew that. They died believing they were targeting ball bearings, tiny components that seemed insignificant until you understood the physics, the industrial vulnerability, the strategic calculus. The legacy nobody expected. After the war, ball bearing production became a critical indicator of industrial capacity. Nations stockpiled bearings. Military planners incorporated bearing supply into war planning. Precision manufacturing capability became a strategic asset. The Soviet Union invested heavily in ball bearing production. China built massive factories. Modern militaries maintain strategic reserves. Because Schweinfurt proved the fundamental truth. Modern war is fought with logistics, supply chains, and manufacturing capacity as much as with weapons. Today, a single M1 Abrams tank requires 3,200 ball bearings. An F-35 fighter uses over 6,000. A Ford-class aircraft carrier contains more than 1 million. The bearings are still tiny, still seemingly insignificant, still absolutely critical. German commanders in 1943 laughed when they learned Americans were targeting ball bearings. They stopped laughing after Schweinfurt. Albert Speer spent the rest of his life convinced the Allies threw away victory by not following up. American planners spent decades debating whether the raids succeeded. Historians still argue about the strategic impact. But the men who flew those missions don't debate. They know what they faced. 381 B-17s launched on October 14, 1943. 60 never returned. They targeted 5 factories producing tiny steel spheres, components that nobody expected to matter, parts that German commanders dismissed as insignificant, until those tiny bearings proved that modern war is won not just by courage, firepower, or tactics, but by understanding which small parts hold entire machines together. The analysis nobody agreed on. After the war, analysts dissected the ball-bearing offensive with conflicting conclusions. The US Strategic Bombing Survey interviewed German officials, examined production records, and analyzed economic data. Their conclusion: there is no evidence that the attacks on the ball-bearing industry had any measurable effect on essential war production. This assessment became the accepted wisdom. Ball bearings, a failed strategic concept. Schweinfurt, a costly mistake. But the same survey contained a critical caveat buried in detailed analysis. The outcome might have been different had the 8th Air Force been able to follow up on the 1943 attacks. Albert Speer's post-war testimony contradicted the survey's headline conclusion. He stated unequivocally that the ball-bearing raids came closer to crippling German production than any other Allied bombing campaign. We anxiously asked ourselves how soon the enemy would realize that he could paralyze the production of thousands of armament plants merely by destroying 5 or 6 relatively small targets. Speer explained why the raids ultimately failed to achieve their potential. First, the Allies divided their force between Schweinfurt and Regensburg in August 1943. Speer believed concentrating all bombers on Schweinfurt would have destroyed production capacity completely. Second, the Allies failed to follow up immediately. After the August raid reduced production by 34%, Germany needed 6 weeks to recover. A second raid during that vulnerable period would have been devastating. Instead, the Allies waited 2 months, giving Germany time to disperse and rebuild. Third, after February 1944, the Allies shifted focus to other targets. By then, German production had dispersed sufficiently that ball bearings were no longer a viable bottleneck target. Speer's assessment: the Allies threw away success when it was already in their hands. British Air Marshal Arthur Harris maintained his position that ball bearings were a panacea target, a supposed miracle solution that distracted from effective area bombing. Post-war analysis supported Harris on one point: Germany never suffered critical ball-bearing shortages, but Harris's alternative, area bombing of cities, achieved even less measurable impact on war production while causing enormous civilian casualties. The debate reveals fundamental questions about strategic bombing effectiveness. Did raids need to completely eliminate production to succeed? Or was forcing dispersal, consuming resources, and reducing efficiency sufficient? Modern analysis suggests the ball-bearing raids succeeded in ways not measured by production statistics. The raids forced Germany to disperse production to hundreds of smaller facilities. This dispersal reduced efficiency by approximately 40%. Producing the same output required 40% more workers, raw materials, transportation, and time. Those resources came from other military production. The workers moving bearing machinery could have built tanks. The rail cars transporting bearings between dispersed facilities could have moved ammunition to the front. The engineers redesigning equipment to use fewer bearings could have improved weapon systems. The raids forced Germany to import bearings from Sweden at high cost. This consumed foreign exchange reserves and created diplomatic vulnerabilities. Allied pressure on Sweden to reduce exports became more effective as Germany's position weakened. The raids forced German industry to use inferior substitute bearings and reduce specifications. This decreased reliability and increased maintenance requirements. German tanks and aircraft suffered more mechanical failures. Time spent on maintenance was time not spent fighting. These hidden costs don't appear in production statistics, but they degraded German military effectiveness nonetheless. The raids also achieved an unintended strategic effect. They forced recognition that unescorted bombers couldn't survive. This recognition accelerated P-51 development and deployment. P-51s enabled the destruction of the Luftwaffe in early 1944. That destruction made D-Day possible. Would D-Day have succeeded if the Luftwaffe remained at 1943's strength? Probably not. Allied invasion forces required air superiority. Air superiority required destroying the Luftwaffe. Destroying the Luftwaffe required P-51 escorts. P-51 deployment accelerated because of Schweinfurt losses. This chain of causation is indirect but significant. Ball-bearing raids didn't directly enable D-Day, but the lessons learned from those raids did. The modern implications. Today's military planners study Schweinfurt as a case study in strategic targeting. The lessons apply to modern warfare. Precision strikes against critical infrastructure can have cascading effects, but adversaries adapt through dispersal, redundancy, and substitution. Sustained pressure is required to prevent recovery. Modern militaries maintain strategic stockpiles of critical components. The U.S. Defense Logistics Agency manages inventories of over 5 million items. Critical components like ball bearings are stockpiled in enormous quantities. Manufacturing capacity is deliberately dispersed. No single facility produces critical components exclusively. Multiple suppliers provide redundancy. Alternative manufacturing methods are identified in advance. Supply chain security has become a strategic priority. Nations that control production of critical components have leverage. China produces 75% of the world's rare earth elements. Taiwan manufactures 90% of advanced semiconductors. These dependencies create vulnerabilities similar to Germany's reliance on Schweinfurt bearings. If Taiwan's semiconductor fabs were destroyed, global electronics production would collapse. If China cut off rare earth exports, defense systems requiring those materials would face shortages. The Schweinfurt lesson applies. Don't concentrate critical production in vulnerable locations. Modern warfare increasingly targets industrial capacity and logistics rather than purely military forces. Cyber attacks target supply chain management systems. Economic sanctions restrict access to critical materials. Precision strikes eliminate manufacturing capability. The ball-bearing raids pioneered this approach. Victory comes not just from destroying enemy forces, but from eliminating their ability to sustain operations. The verdict: nobody accepts. So what really happened at Schweinfurt? Allied bombers attacked 5 factories producing tiny metal spheres. 60 bombers were lost on the second raid alone. 600 men died or were captured in 2 missions. German ball-bearing production dropped 67% after October 1943, then recovered within 6 months. Germany never suffered critical shortages that stopped weapons production. By traditional metrics, the raids failed. But the raids forced strategic changes that helped win the war. They proved precision targeting of industrial bottlenecks was possible. They demonstrated the absolute necessity of fighter escorts. They forced acceleration of P-51 deployment. They led to destruction of the Luftwaffe in early 1944. They made D-Day possible by achieving air superiority. The raids also forced Germany into costly defensive adaptations. Dispersal reduced efficiency by 40%. Imports consumed foreign exchange and diplomatic capital. Redesign efforts diverted engineering talent from weapon development. Most importantly, the raids changed how military planners think about strategic bombing. Pre-war doctrine assumed bombers could destroy enemy morale through city attacks. Post-Schweinfurt doctrine recognized that destroying specific industrial capabilities was more effective. This concept shaped Cold War nuclear targeting. Soviet ball-bearing factories were priority targets in war plans. So were oil refineries, electrical grids, and transportation hubs. The principle remains relevant today. Identify critical dependencies. Target those dependencies precisely. Maintain sustained pressure to prevent adaptation, but by understanding which small parts hold entire machines together. and by being willing to pay any price to take them away. The Germans never expected ball bearings to win a war. They were right. Ball bearings didn't win the war. But the men who died trying to destroy them changed how wars are fought forever.